Okay, today we're going to unbox one of the most famous and maybe one of the weirdest puzzles in all of science. It's got a cat, a sealed box, and a question that totally messes with our idea of reality. So let's get into it. What exactly is Schrödinger's cat?
And here's the man behind the mystery, the physicist Erwin Schrödinger. Now, the first few you absolutely have to know is that he never actually did this to a cat. Phew! This was what we call a thought experiment. Basically, a story he made up to challenge the brand new and very strange rules of quantum mechanics. He thought they were so weird, he designed this whole scenario to show just how absurd things would get if you applied them to an everyday object, like a cat.
And this gets us to the heart of it, the big, mind-bending question. How can a cat be both alive and dead at the very same time? I mean, it sounds impossible, right? In our world, things are one or the other. And that was exactly Schrödinger's point. He was saying, look, if you take these quantum rules seriously, you end up with this totally ridiculous situation. Let's see how he built his case.
To get our heads around this whole alive and dead cat thing, we need to start with the trigger. The entire fate of this poor imaginary cat, it all comes down to the decision of one tiny, tiny particle. Okay, so picture this. Inside the box, you've got a single radioactive atom. And this atom, it's got a perfectly random 50-50 chance of decaying over the next hour. It might decay, it might not. It's a total coin toss. This tiny, unpredictable event is basically the engine for the entire experiment. Everything that follows is a direct result of what this one little atom decides to do.
And this is where reality starts to feel a little bit fuzzy. See, in the wacky world of quantum mechanics, until we actually look at that atom, it isn't either decayed or not decayed. It's somehow both at the exact same time. This unbelievable state is called superposition. The best way to think about it is like a coin spinning in the air, right? While it's spinning before it lands, is it heads or tails? Well, it's kind of both. It's in a superposition of heads and tails. It only becomes one or the other when it lands, when we measure it. That's our atom. It's in state A, not decayed, and state B, decayed all at once.
All right, so we've got this atom in a weird, blurry, undecided state. But how on earth does that connect to a cat? Well, this is where Schrödinger got really creative and a little bit grim with a contraption designed to link the tiny quantum world to our big everyday one.
It's like a chain reaction, a terrible domino effect. Here's how it works. If that atom decays, a Geiger counter next to it picks up the radiation. That click from the counter triggers a tiny hammer. The hammer swings down and smashes a little glass vial full of poison. The poison is released, and, well, the cat's fate is sealed. But if the atom doesn't decay, nothing happens. The cat's just fine, probably taking a nap. So here's the mind-blowing conclusion he wanted us to reach. If the atom's state is directly linked to the cat's fate, and the atom is in a superposition of decayed and not decayed, then doesn't that mean the cat also has to be in a superposition? The entire system, the cat, the poison, everything, is now tangled up in this impossible state of being both dead and alive.
Okay, but this is just bonkers, right? We know this doesn't happen. You've never seen a half-dead, half-alive anything. So what breaks this quantum spell? What snaps reality back to normal? The answer, it turns out, is all about the act of looking.
Yeah, the whole fuzzy, weird state of both collapses into just one state the moment we observe or measure it. That's the key. This is why we never see a zombie cat. The very act of measurement, of opening that box and looking inside, forces reality to pick a side. The instant you look, that cloud of possibilities collapses. You will find a cat that is 100% alive or a cat that is 100% dead. Never ever something in between. The quantum weirdness can only exist as long as it's completely sealed off from the world. And this gets to the absolute core of what Schrödinger was arguing. He was pointing out that there's a boundary here. Tiny little particles, yeah, they can do this superposition thing. But big things like us or cats or even Geiger counters, nope. Why not? Because they are constantly interacting with their environment. They're already measuring things. In fact, the Geiger counter itself is the first observer in the chain. It looks at the atom, and that interaction collapses the superposition way before we even think about opening the box.
All right, let's do a quick knowledge check here, just to make sure this all clicked. It's a final little thought puzzle. So, thinking about that whole setup, what is the very first observer in the box that forces that radioactive atom to stop being in two states at once?
If you said the Geiger counter, you are absolutely right. See, in quantum mechanics, observing doesn't need a person with eyeballs. It just means interacting with. The second that Geiger counter is ready to detect radiation, it's essentially measuring the atom. That forces the atom into a definite state, decayed or not decayed, which then seals the cat's fate one way or the other, long before we show up.
And that was the whole brilliant critical point Schrödinger was making. He never ever thought a cat could actually be alive and dead. He invented this whole crazy story to ask a really profound question. Where exactly does the bizarre rulebook of the quantum world end and our normal common sense world begin? It's a mystery that physicists are still wrestling with today, all thanks to one very famous and, thankfully, very imaginary cat.